With that, we formally move ahead our technical session, the session one, and uh, to our students, Anushka will introduce our first session, the speakers of our first session. That he is the Ramesha B S. He is the uh, head and head of the he is an accomplished professional and with more than 19 years of experience in computer aided engineering and and design, uh, business development, and academic collaborations. He is currently the head of academic initiative at Altair Engineering, where he drives the program that connect academia, startups, and industry. His initiatives include promoting Altair's technologies like HypeMess and Inspire, providing free academic licenses, supporting incubators, and organizing national level student competitions. During his 2 decades with Altair Engineering, Ramesha BS has held leadership roles such as senior manager of academic and startup executive, and earlier managed business development for major automatic OEMs, Tier 1 suppliers, and engineering consultancies in South India. His strong technical expertise in CAE tools and simulation technology has made him a respected mentor and leader. He is also actively engaged with professional and academic communities, serving on the ASME steering committee of MED, contributing as an organizing committee member of SAE Tifan and SAE Baza, with and supporting academic quality such as an IQAC member at AKTU Lucknow. Mr. Ramesa BS has begun his career with BML, working on robotic programming for arc welding and later gained product design experience at Deccan Hydraulics Private Limited. He also holds a master degree in advanced manufacturing engineering from NIT Karnataka and B from Bangalore University. In short, he is a leader who combines technical depth with a strong passion for academics industry collaborations and continuously working on empowering students, startups, and institutions through innovation. Uh, so I here hand over to Ramesh Abhiya sir for his technical session.
Thank you, Sajinji. Thank you so much. Thank you, VC sir, Pragati Kumarji. Thank you, Professor Mutsudan Singh ji from IIIT Bhagalpur. We completely uh, acknowledge the talk and the intention and the effort made towards having this FDP. And this is a need of the hour where the learnings from the industries, learning from the experienced people should get communicated to different parts of the world through FDP program, where we can contribute to the industry or nation development. So thank you. So I will be taking roughly around 60 minutes. I will talk about the power of optimization for sustainable smart product development, taking EV as an example. How Altair, which is part of Siemens, is contributing to the cause. So you may find difficulty in this audio, but kindly listen to this. You can make out from the video itself what is the relevance of our solutions. Okay, if you are not here able to hear the audio, apologies. But the intent of this video, it says that we come across a lot of domains and adding help. I mean, we have a platform to help for the smart product development. So that was the messaging of that particular video. You can check out that video in the YouTube and other stuff. It is available. Coming back to Altair, Altair is present in more than 28 countries with 13 offices. Last year, it has been acquired by Siemens. Presently, since the Siemens is completely listed entity, the merger is happening at the India level. So it might take 3 additional months so that I can use Siemens logo and Siemens slides into my presentations. As of now, I'm using Altair logo for that. So as far as Altair is concerned, we have global presence with usage across verticals like automotive, aerospace, defense, consumer goods. You name, yeah, you touch upon any product in your life, okay, in your day-to-day life activity, you can see the usage of our technology in designing and developing that particular product. That is the most bottom line I can convey to this. So with the acquisition of Siemens, we have a strong CAD system solutions, strong PLM enterprise solutions, strong what you call the systems level modeling solutions to MSC, and strong CFD solutions, along with Altair, which is very, very strong in simulation technology and manufacturing simulation. So with this, it becomes inevitable for any company working on smart product development to use our technology, along with our HPC in data science, which becomes a killer combination. So we're going to cover the usage of our tools and technology as taking an EV an example. Okay, so this slides talk about the smart product development and various categories at which our tools and technologies are being used. These, but let me give you a realistic, simple example to understand. So way back 20 years, right? If you check the product unique selling points of a Bajaj Chetak vehicle, it was completely mechanical in nature. So they were talking about the CC rating of the engine, the maneuverability, the mileage. So these are some of the unique selling point for pleasing the customer. Okay, but now there's a disruption happening in the market. We are moving away from the fossil fuel to electric. There are many advantages. Okay, and because of which, if you see the brochure, okay, the unique selling point becomes Bluetooth enabled. For the rare updates, you can locate the Chetak where you have parked, and if in case of a car, you can also find out where exactly you can park also. So geofencing, okay, and tamper alert. So there are many other features are called smart features, which are making the customer to choose the vehicle, right? They want smart features in the vehicle. They don't talk about okay the mileage other aspect, to be very frank. Okay, so that's the impact of the electrical and electronics, who are the background behind having various smart features. Okay, development happens. Okay, and of course it's a combination of multiple department, multiple technologies associated, but the importance is very, very high for electronic segment. That's what I mean to say here, and I can show you through examples what are the different aggregates which are predominantly used in making this smart product. So this is the slide I'm talking about. Okay, the smartness is all electrical and electronic systems, which is what you call developed over the mechanical systems. Okay, to make it smarter. Okay, so I have identified around 40 to 50 smart aggregates here. Okay, like night vision, ADAS, driverless monitoring systems, even data recorder, you name it, you have a lot of features out there which is making the consumer to choose the vehicle. Okay, they want a smarter product. But important message to the student community is they should know where the investment is coming. Okay, in terms of global investment, the R&Ds are happening. Okay, the companies are spending huge money on electrification. That means moving away from fossil fuel to different forms of energy. One such energy is electrical. That's where you have e-mobility solutions coming into picture, not just in consumer, but also in what you call it, the railways, shipping, and many other areas. AI-driven simulation. Okay, even in our simulation technology, how we can create a meta model for the simulation and predict certain things for parameter fine tuning and other stuff is happening. I can give some examples in the coming slide. Data-driven enterprises. Okay, now the companies have realized the importance of data, what which are being generated over a period of time. So this can be modeled in such a way that it can give certain predictions, predictive and preventive activities can be taken care with this particular data. Semiconductor is booming big time. Okay, people are moving towards cloud. Okay, Corona is the biggest hurdle which made us to think cloud wise. In fact, in our company also, we use simple laptops, but most of the data, 90% of the data sits in the cloud. Okay, even applications are open to cloud. Okay, so in fact, my system is irrelevant to me now. If I have one system, I can directly connect to the my cloud network and I can work on. Okay, so it's an example. Okay, to take it forward. Compliance, risk, and fraud detection. Okay, making important in banking, finance, NBFCs, even companies working in stock market. They realize the importance of this. Even in defense application, they wish to track the pitch and yaw of the drone coming, and they can predict whether this our own drone is being hijacked or not. Okay, so based on the control systems and many things, the features coming from the drone. So again, you have a useful what you called use of data science over here, whether the possibility of a what you called hijacking of the drones. Decarbonization is very important. Okay, they want to have a less carbon footprint, and that's where the mandatory guidelines are given on a lot of companies to reduce the carbon footprint. Right? So these are the areas where the investment is going on, and why I'm taking about this progress slide is you need to know the technologies associated to these disruptions so that your resume becomes relevant to the market. Okay, so the student has to embrace the technologies which are associated to these disruption, and we are in a life where there'll be a continuous disruption will keep on happening. After 5 years, some other disruption will might come into picture, and learnings is part of your life, whether you are in entry level or a mid level or experience level, right? So learning is a continuous pattern. You need to learn, and FDP kind activities really helps people to network, connect each other, share experiences, and learn from each other. Okay, we should be thankful to Jatinji and the entire management of Shri Vaishno Devi University to having these kind of FDPs, helping in the faculties to develop and network with the industry ecosystem. So what is Altair? Altair provides some of the simulation technology and also the global trends in the area of additive manufacturing, autonomous driving, ADAS, big data, cloud computing, digital twin, e-mobility, GPU solutions, lightweighting, machine learning, you name it, you have it. To know more about solutions, please log on to Altair One portal. You can search for Altair One. You get this particular portal and you can check out how we are contributing to these global trends, how our technology can be used. So to simply represent our product suits, okay, you have simulation technology where you can simulate a lot of physics, okay, which includes low frequency electromagnetic analysis, like you can design transformers, you can design sensors, you can design motors, generators, actuators. You can work on high frequency electromagnetic analysis, like you can design antennas, uh, antenna placement, radar cross section, EMI, EMC. You have charging infrastructure, right? How fast you can charge the vehicle, okay? Those kind of simulation. And of course, on mechanical, you have a lineup of simulation technology encompassing multiple physics. Okay, it could be crash, it could be NVH, it could be compression fluid dynamics, multi-body dynamic simulation, and many technologies which helps you to reduce the physical prototyping and you can reduce the design cycle time. So to do these kind of simulation, eventually you need to have high-end systems to solve the problem because these systems are computation intensive, these simulations rather. So Altair also provide HPCs. We don't compete with HP and Dell. Rather, we take those what you call processors or let's say racks, and we can build HPC depending upon the requirement, right? Uh, Even CDAC uses our solutions for optimal utilization of your hardware resources and software resources. So this is building the HPCs for your requirement so that multiple users across the organization can submit a job, not locally but in the cloud, so that there'll be optimal utilization of your hardware resources. At the same time, when you do these kind of simulation, you can actually create a meta model out of these simulations so that you can avoid sudden simulations. Okay, when you have a new part comes into picture, by seeing the particular part itself, the meta model can predict, okay, whether the design is safe or not. Okay, so for that you need to have a platform called RapidMiner. It's a no code low code platform. Most important message here is, many people think that okay, computer science students or its computer science department is the biggest beneficiary of data science, but mm, in reality, if you go to the our experience, the students who know data science with respect to electrical, with respect to electronics, with respect to mechanical, with respect to civil, with respect to bioscience, they have a much better future than the computer science. Okay, because AI itself is disrupting the computer science students. So um, in any engineering college, I have seen certain pattern, like a lot of engineering branches have been there. Okay, within the computer science naming convention. For example, cybersecurity branch, data science branch, information science branch, all are well connected in computer science only. Okay, but the demand is less for certain core branches like electrical, mechanical, and civil, those kind of areas. But eventually, these things will overcome, and there's a need for the students from these core branches to identify their branches. They need to build industry skill set, which can really make the area much smarter. Okay. So coming back to my portfolio, I told you HyperWorks is a simulation platform. SmartWorks is all about data, what you call it, HPC systems and IoT applications, and Rapid Managed Data Systems. So these three technologies put together help me in creating a digital twin. Okay. So digital twin could be data driven or physics driven. Okay, I can go in detail, but due to lack of time, I will reduce here. So in simple, the messaging is very clear. Altair, along with Siemens products, we give you a platform for digital twin, okay, which in turn refers to a smart product. Okay, what are the technological disruption happening as far as these mobility is concerned, and how different sectors or different pillars of this e-mobility are helping the ecosystem? Okay, government have come up with the NCAP, Bharat NCAP, if I'm correct, right? So they are pushing mandatory safety features, but there's less details on the ADAS. But in India, if you can see, only level 1 and level 2 ADAS features are being implemented in vehicles. Okay, majorly it's EVs. Okay, for example, lane detection, lane departure warnings, adaptive cruise control, autonomous braking in case of emergency. Those kind of features are already there in cars like Mahindra XUV, Hyundai Creta, and Victoris, I think, in Maruti. Okay, it's a new car. Just 1 month back, they have released. This contains ADAS features. And the technologies will keep growing. It might take 10 to 15 years to have high level ADAS up to level 5, where all the features, functionalities will be available. In fact, the whole core objective remains the same. Okay, to have a safe driving. Okay, and the abnormalities in Indian condition is very high. Okay, you have poor road. There'll be what you call demarcation of lanes are very not correct. Okay, there are huge challenges when you want to develop these technologies, and the in-house companies and startups are working hard to develop technologies so that we can contribute to the cause for smart product development. As far as EV is concerned, in mechanical systems, we have various subsystems. Okay, and power electronics plays a very important role over here because they can't share the same power. If all these systems start grabbing the power, then there'll be a huge impact on the power source. Okay, so I just to give you an example how we are helping the students. Okay, there are various competitions which are conducted in around this. Okay, one such event is SAE Baha. Way back 10 years, we started with mechanical Baha, and then we moved to electrical Baha, and different fuel systems have been used like hydrogen Baha and other stuff, other what you call blended fuel systems as part of this Baha competition, so that the student can design their vehicles as per the new requirements. Presently, from past 2 years, we are also conducting a Baha, which is nothing but autonomous Baha. Okay, Believe me, this is the need of the hour, where not only we learn things in lectures, in as part of academic curriculum requirement, plus contribution from industry, we learn a lot of things. But unless you put your hands mud, right, you have to design and develop certain things. Then only the huge learnings will happen, right? So I request all the colleges to explore these kind of challenges, make the student to participate in these challenges, so that a huge amount of learning happens when they practically create and develop systems. Okay, the theory and practice, there'll be a large difference will be there, and those energy gaps are, let's say, can be covered by participating in these kind of events. Presently, it's happening in Chennai from 8th of October to 12th of October. Any faculties in and around the colleges who are participating in this what you call FDP can also reach me out there to have further interaction. So, in terms of simulation technology, you go to any standards. There are homologation agencies like ICAT, let's say ARI. They give design guidelines. They accept simulation results as part of verification of the product. Right? They are the people who give approval to vehicle to run on the road in Indian conditions. Right? So they approve all these load cases. I'm trying to list the load cases. Okay, on the bottom in the boxes. On in the top, you can see the different Altair tools which are used. The first one is all about structural. Of course, I want to reduce the structural explanation much lesser, but let me directly jump on to EV. That means electrical content more. When you want to design motors, okay, validate your motors, there are a lot of load cases which are being covered as part of ARI, like stator and rotor design, electric magnetic losses, performance efficiency curves, torque ripples, we call it as motor rod torque ripples. Those kind of simulation can be easily done with the help of our tool called Flux. So Flux is a tool which is a low frequency electromagnetic analysis tool. Okay, and very important is you are not just limiting yourself to low frequency electromagnetic analysis, but also the multi physics part of it. Okay, what is noise induced by the motor in the running conditions? Okay, what are the thermal effects if it is running for more than 8 hours or 10 hours? Those kind of challenges can also be achieved in tandem with the structural simulation solver. Okay, that's the message. Once you design a motor, you need to control the motor. Okay, that's where you have to work on mathematical modeling. Okay, modeling and we call it MBD. Okay, system level modeling tools, 1D modeling tools, where you can design the battery pack. You can design the controllers. You can do embedded programming through Altair Embed. You can do power electronic simulation through using piecing. Okay, of course, I'll walk you through the site through which you can download all this. It's free for any student across the globe. It is not for the institution because institution collects fees, so they need to buy it separately at a very discounted price. But for students, it's available. Even the learning platforms are available how to use this particular technology, and there are courses through which the students can what you call challenge themselves. They can get certified in the courses and they can get a certificate. Okay. So you can control the what you call design the what you call programming for various targets. Okay, for example, you have Arduino boards, Raspberry Pi, TI chips are there. Okay, a lot of chips are there. There are 1,500 targets are there. I don't know most of these targets for which you can do embedded programming. You can do hardware in loop, software in loop, those kind of simulation with a platform. Once the system is ready, you end up using a lot of sensor to track the data. Okay, in real time. Okay, and real time you can track this particular data. Okay, very very important. So our data science tools like our rapid miner can be used on real time data acquisition through Panopticon, so that you can find out the what you call the real information on the vehicle. Okay, and that's the essence of any distributed platform. Okay, and it's a low code no code platform. Students from other branch of engineering no need to worry about the programming aspects. Okay, they can drag and drop the data. It can help you to follow the ETL process, and of course, you can create a machine learning model. There's an auto ML feature is available that automatically creates a machine learning model. You can verify the machine learning model by giving one more set of data and verifying its results. Okay, so that there'll be higher correlation coefficient. between the machine learning model and the test data, the verification data that you have. Thereby, you can deploy this machine learning model on the various targets itself. So, edge computing can happen with those solutions. And apart from this, as far as mechanical simulations are concerned, some other additional advantages also there. When you say mechanical, the certain simulations like forming, extrusion, molding, 3D printing, casting. So these are all manufacturing simulation which can be done upfront with our platform, so that the product, whatever you design, is ready for manufacturing. Okay. So one such feature is Altair Inspire. Let me show you some videos on this so that you can understand how powerful it is. This is the platform through which you can create CAD geometries. You can do structural analysis, both linear and non-linear. Of course, there are various analysis which you can perform. You can do optimization. Once it gives you a distribution, you can also create what you call parabolic surfaces, okay, on top of it, and you can rerun the analysis with the optimized geometric distribution. And of course, the manufacturing simulation can also be done over here. Okay, there are many other features are there. I'm just giving examples here, okay, about the manufacturing like casting, forming, injection molding, extrusion, additive manufacturing, and also the foaming applications. We have various solvers, not only for the system simulation, okay, starting with multi-body dynamic simulation. We have manufacturing simulation, which I explained in the earlier slide. We have electromagnetic solver, both low frequency and high frequency. We have structural solvers for linear, non-linear, multi-body dynamics, and more. We have crash solvers for safety and impact, and also the blast simulations, which are highly nonlinear in nature. We have thermal analysis tool, both CFD and structural conduction, convection, those kind of problems can be solved. We have 9 different types of fluid solvers are there, okay, for different application. The last one is, which is one sub part of this fluid dynamics, where you are handling a bulk material, okay. So it's a particle simulations solver. And of course, many of our simulations, you can move the results from one solver to other solver, so that it becomes a interdisciplinary simulation, multi-dynamics kind of simulations, okay, multi-physics simulation rather, okay. So which are part and parcel of our solution portfolio, which are well integrated in the system. Okay, so the students who want to learn basics of EV, they can start with this 1D simulation. Mathematical toolboxes are available to design battery pack, design controllers, and many things. All other tools are well integrated here. You can bring in a multi-body dynamic simulation as part of your system integration, right? It's not like a task-based automation. You can drag and drop. You can change the design requirements of a particular box, and accordingly you can do a task-based automation. Okay? And that's where the 1D simulation strength comes into picture in designing the overall specifications of the vehicle or the subsystem or aggregate. And of course, for detailed simulation, you can always move to 3D world in real time. You can simulate it. One such video is available on the mechanical systems, how multi-body dynamic simulation are being simulated in one such platform called Motion View and Motion Solve. Motion View is a pre and post, that means pre-processor and post-processor, and the Motion Solve is a solver name in Altair, through which you can do multi-body dynamic simulation to capture the road load data. Okay, this is the first input to simulate any aggregate or any component in any vehicle. Okay, the load data. Okay, so by simulating the dynamic behavior which can be experienced by the vehicle, you in a time domain you extract the load data that is given as an input when you solve a structural simulation. So let me move on. So this is the one simple slide I just added, okay, in terms of where are the tools available for the students to explore. Okay, as you can see, it is applicable to industrial design. Okay, people are working on architecture, they can use our solutions. Concept design and simulation applicable to civil and mechanical. Manufacturing simulation applicable to civil and mechanical. Aerospace. Model-based development applicable to all branches of engineering, like electrical, electronics. Okay, you have compose, activate, embed. Plus PSIM for power electronics. You have multi-physics, multi-geometry optimization solutions through SimLab. We have advanced modeling pre and post. Okay, predominantly mechanical engineers use this. We have advanced solver technology, again mechanical, along with electrical electronics. Different solver technologies available here. For data analytics, we have Altair Rapid Miner. Okay, Monarch is a data preparation tool. Knowledge Studio is dedicatedly for banking and finance sector, and Altair Rapid Miner is a open-ended data science tool where you can create predictive analytics on the data. And of course, for architecture and civil engineering, there are some dedicated tools like S-Frame, S-Line, and S-Concrete, which is only used by civil engineering students. Okay, so all these solutions are available in our portal. Please search for Altair Student Edition. You get a landing page where any student should be able to download this. If they have academic email address, they can get 1 year license. If they don't have, they can go to respective product page and they can download the trial license. Okay, and it is only for personal usage, not for any institution usage as such. Okay, let me give one example here. Again, I have a video, but I will try to explain how easy to do a simulation in Altair Inspire. Okay, I assume you are not able to get the audio. So this is how the window looks like. So Altair Inspire, where you can create a mechanism and accordingly you can simulate a dynamic effect on a control arm. So when you do this kind of simulation, it does an optimization on top of it, which tells you the optimal material distribution required to take care of this particular load. Okay. Only that material distribution is sufficient to handle. Remaining material we're going to remove. So as the theme says, we want to reduce the weight of the vehicle without compromising on the performance. It is not just reducing the weight, but also it is what you call satisfying other physics performance criteria. For example, I want to make sure my natural frequency should be less than this. I want to make sure my fatigue life should be less, should be more than a particular value. So like this, any physics that you simulate, any performance that you measure, that can be used as a constraint or an objective in this kind of optimization. And once you get this distribution, you can create a polynomial surface, okay? And quickly you can do the simulation by encompassing in this analysis. At the same time, you can do manufacturing simulation like casting or 3D printing, those kind of simulations. Okay. So that means in one window itself, you are doing various simulation and you are taking the data from one platform to other platform in one window. And let me move very fast here and explain you about one such other solver, which is this is again an Inspire. But the thing is, many times whenever you have a model, you need to change certain parameters, which can easily be changed over here. And very important thing is we have a solver which is called SimSolid, which is a very powerful solver, which uses polynomial equations to solve the problem. Unlike you have finite element method techniques where you have a lot of degrees of freedom. So when you use polynomial equation to solve a problem, it has less number of degrees of freedom, and that's why it solves the problem very quickly. At the same time, this kind of solver becomes very, very efficient when you have a large assembly. For example, civil students, okay, they work on structures like Howrah Bridge or let's say Paris Tower, where the number of components in the assembly itself crosses like 70,000, 80,000. So to handle such a huge data, it's a joke for our tools. Okay, it can quickly create contacts, can quickly create and do the simulation. Okay, because number of degrees of freedom is always less. And even if you have a simple system like a simple cell run system, you should be able to solve the problem. Okay. So watch out more on these tools from our portal. So now I have covered various aspects of our technology, our simulation technology, which is adding value and creating a smart product. But let me jump on to one such cream level tool, which is called OptiStrut, where we use this technology before creating the CAD geometry. Okay. Generally, most of the engineering students think that, okay, we have a CAD geometry, we take that as an input, and then we validate your design, right? So it becomes a CAD-driven approach. But what Altair prophecy is to use CAE upfront before CAD. And that is the example which I want to narrate through these slides. So in olden days, we never had any systems. That's why we used to use mini drafters to create a CAD geometry, and that is given as an input to the shop floor to create a prototype and to test it. And if the performance criteria is good, we go for production. If it is not, again they have to go back to CAD tool to redesign this. Okay, it's a very iterative process, but with the advent of systems, we can use what you call CAD tools. Okay, like we have Siemens UGNX is available, Solid Edge is available. It's a CAD platform. You can easily create CAD geometry. You can modify the CAD geometry very quickly. Okay, that's the best point. But once you use this CAD driven, again you will not eliminate the what you call the iteration, right? Because you have to modify the design and come back. And that's where the CA comes into picture, where you're using CA upfront before creating a CAD geometry. Okay, that's what I was referring to in the previous video, where they've done the simulation, they have got the optimum material distribution. That distribution is acting as an input to the CAD process. Okay, because that distribution, what we got, is satisfying various analysis requirements. Okay, performance criteria. Okay, so how we can conceptualize design is through Mother Nature. This is one such example I'm giving you over here. If you take a penguin, it can flow or let's say maneuver inside the water very easily. It can maintain its drag and lift coefficient. It can come out of the water also. It is optimized by Mother Nature. The birds can fly in both low altitude as well as high altitude. The wingspan control is the essence behind this. Honeycomb structure, it can store large volumes of fluid, and because of which it's also called a composite, because it has highest specific modulus and specific strength. That's where you can see the usage of honeycomb structure in space industry, right? So again, it is what you called developed by Mother Nature. The bamboo tree, which has highest torsional rigidity. Okay, if you use torque equation, you can. I think my professor have taught me about torsional rigidity to torque equation, where they have said hollow structures will have highest torsional rigidity, right? That's why if you see a cycle frame, it is hollow, it is not solid. Okay, and that's why in our olden days also to construct any tents or home or structure, they were using a bamboo tree. Okay, it's a structural member. Okay, so there are a lot of science behind this. It's again optimized by Mother Nature, right? And if you don't have that kind of intuition to observe nature, you can always use tools like OptiStruct from Altair to leverage this. One such example here is it is in Stuttgart Airport in Germany, where the pillars look like tree. It is what you call inspired from Mother Nature tree structure. Okay, so this is very important slide for all the branches of engineering. Whenever you try to simulate certain things, right, you have scope for optimization. Okay, the first four forms of optimization is typically mechanical in nature, like topology, free size, topography, and free shape, which are used. Which are the optimization technique are used, which are before CAD. Before creating the CAD geometry, you do this to get a very good inference to CAD geometry. Okay, as an input to the CAD process. The shape and size kind of optimization applicable to any branch of design. For example, I want designing a motor. Okay, I want certain characteristics or performance criteria of a motor, and to achieve this, you have certain variables, right? So how I can modify these variables? What is the impact directly and indirectly? Okay, even if you have 10 variables, okay, in your design, okay, and you have two levels for the design to change, okay, the uppermost bound or lowermost bound, you can imagine the number of analysis required to verify the slope of each parameter, right? The slope can be positive or negative or neutral. Okay, that's where the parameter screening is very very important, and that's where the tools like hyperstudy, it's a completely mathematical code, is very very efficient in designing a best antenna, designing a best motor is applicable here. So you can identify parameters which are influential on the performance and give to this code, and it will tell you these parameters are influential on the performance. Okay, you can take only those parameters to optimization, give the uppermost and the lowermost bound. It might have infinite points, but it does sampling and it does the mathematical model on top of it, and it will give you the best parameters suited to achieve certain parameters. And when you are doing this, it is not limited to one physics, it could be multiple physics here. Okay. And Believe me, this is the tool which we're using from past 30 years to design and develop. And now they call it as data science. Okay. They talk about machine learning and everything. And this is what the machine learning, where we represent the physics through mathematical modeling and use this mathematical modeling for um, parameter screening and also for optimization. This is our way of digesting machine learning technology. Okay, I want to design a chair. This is a very good example, simple example. There'll be a sitting area and a non-sitting area, and you have a loading locations. The yellow arrows indicates the people sitting on the chair, the load, how it is being distributed on the seating area, which is nothing but a down design space. It is sitting on the floor, so you can apply four constraints at the four corners, and of course, this is a mechanical example. So if you solve this particular problem in the design space, it will remove material in such a way that the forces which are acting on the seating area get constrained towards the constrained location, get transferred to the constrained location. That's why you get distribution like this. It's like a four-legged design. Okay. On the other hand, if you make some changes in your design, for example, instead of constraining at the four corners, I'll create a circular ring and I'll go to constrain the circular ring. So you get a two-legged design. If you change the design space like a hourglass, you get a different design. So this is very important slide as far as mechanical engineers concerned. Whenever they are doing upfront CAE, before, that means concept engineering, they are getting concepts. So it's going to come up, helps the student to create a lot of concepts which satisfies the engineering requirement and the performance requirement, but aesthetically may be different. Okay. But if you take one such design, the way you realize things, okay, it could be different. For example, I can go for a four separate tube structure or two bent tube structure, or I can go for a forged component. The way you realize may be different. Okay, but eventually it will satisfy the necessary performance criteria here. And this is the importance of concept design in day-to-day life. Again, one more example. I want to design a bridge. I don't know how the bridge looks like. I will take a brick shape, two-dimensional element here, two constraints representing the shore. One strip of element, I will make it as a road, okay, where there'll be uniformly distributed load representing the vehicles, okay. And I will try to solve the problem like topology optimization for maximizing the stiffness, okay. Initially, what it is at the back end is it actually identifies the what you call the strain energy density of each element pertaining to the load at the zeroth iteration, assuming full element, full density in the element. But in the second iteration, it will try to reduce the density by some percentage and see the effect on the strain energy density. If there is a substantial change in the strain energy density, then it means the element is contributing and you have less scope to reduce the density. And again, you're not reducing density, it's actually a penalty factor. So like this, it runs through multiple iteration and finds out the elements which is contributing and non-contributing based on the strain energy density value. And what you see is the plot is nothing but a density plot. It tells you the optimal material distribution satisfying the constraints as well as the objective function of the optimization. Okay, that's why it is called density plot. So in terms of color, if I want to explain, the dark blue region indicates the elements which have lost the density. Okay, from say 100% to zero. That means it has become from steel to paper, right? It doesn't have any what you call load carrying opportunity, right? It's not carrying any load, and that's why you can completely take out these elements. And this distribution give you inference about how the structure should look like, and structural engineers like civil engineers can create a trust number out of this distribution. It gives you an inference. Okay. At the same time, if you move the road to the bottom, you get a different distribution, and you might have seen certain bridges of this particular shape as well. Okay. So the whole intent of giving these examples is you can leverage these technologies for various design requirements. It could be electrical engineers or mechanical engineers. They need to design certain parts of mechanical nature. You have a scope to use the tools for your requirement. And of course, our tools helps you to use your performance criteria as objective function or let's say constraint. So in any optimization, you will have objective and constraint and variables. Okay, this is one such video again from the students, how they have leverage in designing a drone structure I want to skip this so that I can show the end product directly over here. So this is a distribution what they got it from 3D printing, again through concept generation. They have used our Altair embed for controllers, controlling the motors and other stuff. And this is the drone which is flying, which utmost stability. Okay, let me move on to next slide. Again, this is a commercial example here from Airbus. They have designed a very lightweight bike structure. Okay, you can search in Google about AP Works bike. It's just 37 kg. It's an electric bike. Okay, developed through this optimization technique. Okay, so this is a lightweight bike. The frame weight is 6 kg. Of course, they are using uh, aerospace alloys. Okay, that's why it is so very lightweight. So in simple, the essence is simple. You have a scope to use. And of course, there's second type of optimization, which is called topographic optimization, which is addition of beat pattern. For example, if you take a kerosene can, you are not able to put the lid because if it is filled with the oil or let's say fluid, the walls used to buckle, right? To avoid this buckling, I want to improve the stiffness. There is no scope for me to add material here because you are using a sheet metal component here, and that's where the bead patterns comes into picture. Adding a bead pattern will improve the stiffness locally. How scientifically you have to do it is given by topography optimization, which is one of the forms of optimization in OptiStrat. So this is a bead pattern which they have created, and now you can compare the initial and different other forms of bead pattern. No matter how many beads you had it, okay, the deflection is very less in case of first pattern given by the operation solver. So and of course, for frequency domain problems is very, very important here. All automotive industries who are working on body in white, you might have done frequency domain analysis, but there's a local, what you call resonance happens, okay? Global mode and the local mode. We use the two terms here. The first six natural frequencies are global, but the local node, maybe 56th frequency, may be creating a huge noise somewhere in, let's say, your mirror. Okay, so how to identify those local frequencies, resonative frequencies, can be identified and subdued locally. That means localized stiffness improvement can be done to reduce the effect of such resonance happening in the frequency domain problems. So this size optimization, which is nothing but topography optimization, is very, very helpful in achieving this in body in white. And of course, the shape and size optimization applicable to any branch of engineering, any part that you design. Okay, it is very, very helpful. You can. It's a mathematical code hyperstudy which can help you to achieve this. It can directly link to your solver, verify the performance, and come back and fine tune the parameter here. The effect of changes in these parameter on the performance. Okay, and skip this size optimization. Also, size is playing directly with the thickness of the sheet metal, and shape is something you can modify it. And this is one such example from the aerospace where how they have used all these four different types of optimization to reduce the weight of the ribs. There are 13 ribs on each wing, so total 26 ribs are there. They could be able to reduce around 500 kg with 7 weeks of effort. This is the Airbus example here. Now, very important side as far as electronics domain is concerned. We have a tool called FICO, which is used for high frequency electromagnetic analysis. Many analysis like antenna design, antenna placement, radar cross section, EMI, EMC, even the what you called battery charging can be done with this. Okay, of course you are not able to hear this audio. I request you to watch out the same in YouTube. These applications are given here. Okay. Let me skip to next tool, which is Flux. It's a low frequency electromagnetic analysis tool used to design and develop low frequency electromagnetic analysis tools like generators, motors. There's a video. Of course, no audio is required for this. Okay, you can watch out this. You can design transformer, any application or what you call tools which is working on low frequency electromagnetic analysis. Okay, the BLDC motors, permanent magnet motors. Okay, those can be designed and developed using these tools. This is called wireless charging application, windmills. So there are huge amount of literature available how you can use this technology, and of course there are IITs, IIT, NITK, Surathkal. There are a lot of published technical papers. IIT Madras have published on technical papers. Anybody wants, please connect me to LinkedIn. I will be sharing on these areas also. It should be very useful to you. Okay, let me move on to one more relevant tool, which is called Embed. I'm not expert in embed, but I am trying to collect the information here. So for a lot of targets, you can do embedded programming, you can do hardware in loop, software in loop, those kind of simulation very easily with our solutions. At the same time, not only embedded programming, but also power electronics applications, right? So there's a small video here. Again, there's no audio to this video, but you can see the video and make out uh, what is the relevance of our solution called PSIM. PSIM. Okay, it is embed one. Let me show you the next one, which is PSIM. So again, there's a video. Let me show you that. So the intent of encompassing my presentation from mechanical to electrical to electronics to power electronics is very, very important. This is the need of the hour to develop any electric vehicle, right? You have various systems and subsystems which make the product smarter, right? So without this is not possible. That's why if you see the Baha competition, the students are from different branches of engineering coming together to design and develop a autonomous Baha. You have students from computer science background, you have students from electrical, electronics, mechanical, even for civil that particular matter, they come here, they contribute a lot, and together they make a product. Okay, with this they understand team efforts. Okay, the importance of working together. Okay, the character and conduct, the attribute is being developed over here. Okay, that's very, very important for participating in, let's say, contributing to any company, right? We are from different people, different sections of our life, different languages we speak, but we come together for a common cause, right? And that's what the huge learning happens when the student participate in these kind of competitions. I'm almost at the end of my presentation covering a tool called RapidMiner. It is used for data science. It's a number one data science platform, and it's a no code, low code platform. No code means you don't need to learn coding for digesting artificial intelligence and machine learning. Okay, it's a low code. Why we use it? Because even if you have a code, you can use it and modify it here, and you can see the usage of these solutions across multiple verticals, not only from the industry segment but also like banking, finance, NBSCs, companies working on stock market, large data, smart cities, smart building. They use our solutions, and our real-time data acquisition tools like Panopticon. We have conducted a simple student competition, okay, where they can create app using MSIM, and they track the data, and dashboards are created through Panopticon. Okay, so this is the way where we can talk about our technology to a domain where the student will understand what is real-time data acquisition, why it is needed, how I can apply this to a large scale machinery or a component, and how I can leverage predictive or preventive maintenance and those kind of areas. Okay. Initially, when we learn machine learning, we think as a subject, but we need to think in terms of applied science. Okay. So believe me, the student contest really help to bridge this particular gap, and they love the technology when they start applying these things. They talk about the protocol, they talk about the how at what speed how to capture the data. Okay, in milliseconds or minutes or hours, those kind of data. how much or large volumes of data is being captured, what data I have to capture, whether the data is relevant or not. Lot of questions getting answered when you use these kind of tools. Okay, on a competition basis, because competition is the only where we we see a lot of interest coming from the students. And that's why if you see my LinkedIn post, I keep conducting a lot of contests. Okay, there's no fees for participating in this contest. Many of our contests is open-ended challenges. Okay, so please let your student to participate. They get visibility, we get very good quality students. We evaluate these students based on how they understood the technology, what technical words they use when they capture a video about the problem statement that they have solved. Thereby, the industry will get the bright students. Okay, so there are many things which I want to speak, but due to time limitation, we're going to stop it over here. Um, Again, in summary, this is my essence. The overall intention of this story is Altair, along with Siemens, is a platform for smart product development, not only applicable to electric vehicle, but any form of product design. It really helps you to design and develop from end to end. Okay, and we have students portal through which any student should be able to use all these technologies. There's a portal through which they can learn. Model files are available, video files are available, like a Moodle platform. They can leverage it, and they can also participate in these challenges. At any point of time, there's no fees for this. Okay, it's free. Only the interested students are the real beneficiaries and real value system for us. Okay, so that is the message I want to give to her here. If you have any further questions, kindly connect me through LinkedIn. I'll be very happy to help you. So with this, I will conclude my presentation. If at all any queries, I'll be very happy to answer these queries. So over to Sachinji.
Hello, am I audible?
Yes, sir.
Yeah, yeah, sir. Thank you so much, sir. Thank you so much for giving the great presentation on the topic. So first, I will ask the participants if they have any questions related to the topic. You can write in the what's
We lost the audio, Sachinji, but I'm trying to show you what is the link to download software as far as Siemens is concerned. And also you can search for a simple keyword like Altair Student Edition. Okay, if you search this, you get this particular portal called Altair Student Edition, and here you go. Any information that you want is available over here. How to download, what domains it
hello.
is supported. Yeah, I can. We can hear you, Sachinji. You can
Yeah,
go ahead, please.
yeah. Am I audible, sir?
Now it's audible. Yes, please, please go ahead.
Yeah. So actually, I just one question.
Mhm.
So, what are the actually the biggest challenges in industry face by integrating the optimization methods into product lifestyle cycles, or we can say the supply chains?
Okay. The biggest hurdle to the industry is resources, to be very frank. But as far as optimization is concerned, the practical
Yeah.
experience we don't have. Okay, we even let's say I'm an engineer working on a tool. I know most of the knowledge from the tool, but unless I design and develop a tool with my hand as part of a team, I may not be able to learn. Okay, over a period of time, since I'm an academic initiative head, I'm interacting with students. I sit with them, understand the pain points, and I could contribute. And the same time, a lot of experts they come together, they share ideas, they help the students. So through this learning, I have learned a lot. But eventually, the people who are working in the industry, they lack a lot of information unless they work with the people on the real time basis. Okay, they make their hands wet. Okay, that's what the word you use, right? You design develop yourself, then you understand the pain points. Okay, so that's why we give a lot of what they call the opportunity for the engineers working in any company to participate and help startups. So startup ecosystem, they have huge challenges. They are the people who apply very seriously. They have put money on the design and development of any part, and by associating with them, helping them, our engineers will learn a lot. Okay, And we sit with the customers when you are applying optimization technique, right? The questions what they get, the problems what they get, we solve those problems through which we learn a lot. So hope I have answered your query.
Yeah. Yeah. Thank you so much, sir. So I also got the one questions from participant that that what roles does AI ML based optimization play in accelerating sustainable product design, sir?
Excellent question. Okay. For example,
Okay.
let's say I will take very simple part. In automotive, you have a door. Right? When you want to design a particular door, right? There are more than 32 load cases out there. Okay. How do we learn this? By field, we learn. Okay. These are the ways through which my door can be destroyed, or let's say it may what do you call design failure can happen. That is called load case. So we take this load case to design any load, any door. But over a period of time, okay, have designed and developed more than, let's say, hundreds of vehicles, hundreds of doors for these vehicles. So I have a legacy of different varieties of doors available. So now, when I want to design a new car one more time, okay, I don't need to go to the same process of creating a CAD geometry and applying all these load cases and solve the problem and verify it. Okay, with the advent of this machine learning, I give the multiple analysis whatever I have done over a period of time on the door as an input to my machine learning tool. Okay, it actually takes the essence of all these load cases, models, and various features. By having this as a data, it can easily tell you whether the incoming door is safe or not for all these load cases. Okay, so I can eliminate what we call a huge process time required to approve the door frame because of this machine learning model. So in simple, I can reduce the design cycle time to a great extent, and there is an impact what is creating this machine learning is creating on the mechanical engineering simulation technology as an example. Hope I've answered your query as one example. There are many examples out there.
Oh, yeah. Thank you so much, sir. Thank you. Sir, thank you so much. Now, uh, from the uh, whole team of our SM video and the from participants, I am very thankful to you, sir, for giving the expert lecture on the this topic. So thank you so much, sir. Thank you. We are really delighted to have you as a speaker in this at LFDP, sir. Thank you so much, sir.
Thank you, Sachinji. I'm showing
Thank
my profile here. Anybody who not able to ask any question, want to know more about, please connect to me. I'll be very happy to help you. Okay. And thank you
Yeah.
so much, Sachinji and Jitinji, for giving me this opportunity to contribute. It's a very heart-warming, warm interaction contributing to this FTP. Thank you so much.
Yeah. Thank you so much, sir. Thank you.